let's kind of dive in with questions from you guys. So at this point, we've had a fair bit of assignments kind of racked up here. We can talk about specific things from homework or kind of broad ideas in general, if things you don't understand. Grace, we'll start with you. Sure. Just get the date on this thing real quick. Worksheet 2, question 1. Okay. So here we're asked to construct a sinusoid. So that means either a graph of a sine or cosine function, where it says the amplitude is 5, the period is 6 pi, and it passes through the point -2, 8. So first thing I'm going to do is decide whether I want to do a sine or cosine function. My deciding factor is going to be the type of point that I'm given. Here I'm not told anything about the point, like it doesn't have to be a maximum or a minimum or a midline point or something else. Thank you. Grace, it's for you. Okay, sure. Natalia, it's for you. You're welcome. So we're not told that this point needs to be a maximum or minimum or whatever. It just has to go through it. In that sort of situation, I'm going to choose to use sine as my function. And we'll explain why that is easiest in a moment. Now, you could use cosine. You won't necessarily get the wrong answer. It might be a little bit more work, but you know. All right. So first things first, I'm going to start with the amplitude. I know the amplitude is the same as the absolute value of A. So I know that A is either positive 5 or negative 5. I'm not sure which one yet. We'll decide that in a few minutes, but I know that much. And I know since the period is 6 pi, I know the period is 2 pi times the absolute value of C. So I can use that to solve for the absolute value of C by dividing both sides by 2 pi. And now C could be either then positive 3 or negative 3. There's correct answers either way. In my experience, it's never easier to choose C or to find an answer where C is negative. And since there's answers that work for both C being positive or negative, I'm just going to choose the C to be positive here. I'm going to do that in every single problem that I do. Not that you have to do it that way, but I think is, again, like oftentimes we're just looking for the simplest or easiest way to do that. I think that just making C positive every time accomplishes that. Okay. So the next thing I'm going to do then is to figure out my H and K and also my sine for A. I'm going to get all of that from this point, -2, 8. Since I chose to use sine, I'm going to pick a point from the parent function and match it up to this point in my transform function that I'm dealing with. Basically, you know how like when we're graphing, we transform one of the points to the parent from the parent function to a new point in our graph. We're basically doing the reverse direction here. Now the question is, what point from the parent function do I want to, did I want to send to -2, 8? The easiest one to use is 0, 0. Now if you think back to the graph of sine, 0, 0 is here. That's a midline point. And there's actually two different kinds of midline points. Notice left of 0, 0 is a minimum, and to the right is a maximum. But say had I talked about this midline point, left of that is a maximum, and right of that is a minimum. So there's two different kinds of midline points. Is that okay? Okay. Now, the type of midline point that negative 2, 8 is going to dictate whether the a is positive or negative. So when we're doing this matching back to something from our parent function, we have to match up like midline points to midline points or extreme points to extreme points. Is that okay? Okay. So I know that negative 2, 8 has to be a midline point. If I'm using 0, 0, which is what I'd like to because it makes the rest of this much easier, and we'll explain why in a minute. So I have my choice, which type of midline point do I want negative 2, 8 to be, because we have the freedom to choose because we're not told it has to be, anything. So I'm just going to make it the same kind of midline point that I had before. So that's going to tell me the a is positive because these are really the same kind of midline points. Is that okay? Because this type of midline point is the same as that type of midline point. Correct. If you had chosen negative 2, 8 to be the maximum midline point min kind, then the a would need to be negative. Okay with that? Okay. And now that I've made this pairing, since the x-coordinate on the parent function is 0, the x-coordinate for the transformed function is going to be the h. And because the y-coordinate from the parent function is 0, the y-coordinate from the transformed function is going to be my k. And now I have everything that I need. And you could simplify that stuff down inside the sign or whatever by distributing 1/3 through if you want, or not. Either is fine. Does that feel okay? Yeah. Okay. Follow-ups to this one before I move on to something else, Elizabeth?
So basically, you have another reason as you use cosine.
Right.
So for all the other ones, you use sine.
So I would use sine for number 2. But I would use cosine for 4 because here we're told that that point has to be a minimum. So that's why I would use cosine there, because now I can't use 0, 0 for sine because that's a midline point and not an extreme point. So whether it's a midline point or a min or a max or a min is basically going to help me decide whether I want to use sine or cosine. Does that work for you?
Yes.
Okay. Josie?
You do number 2.
Sure. Is there another follow-up to 1 before we move on to look at this one?
Well, just a little question for what you just said about the minimum.
Yeah.
When you find the parent one from the points that we are given, can you name it whatever, or you can find one that is a minimum?
No, you can use 0, 1, which is
And then just say
a maximum. No, that's a maximum. But you can match any extreme point with another extreme point. Right? There's 2 kinds of extreme points. There's a max and a min.
Yeah.
Just like there's 2 types of midline points.
Yeah.
There's the min max or min midline max and max midline min. And you can match any type of extreme point with any other kind or any other midline point with any other. If they're the opposite kind of point, that's what's making the a negative.
How do you know if it's an extreme or not?
Well, their mins and maxes are your 2 extreme points.
Yeah, is that like, how do you know which ones are which?
Well, in this problem, it tells you.
Well, when you use the other one, the one that you give us.
Oh, well, if you just look at the graph of cosine, that's a maximum, right?
Yeah.
So
like, what point would that be?
0, 1.
Thanks.
Is that okay? So really, every time if I'm using cosine, I want to use 0, 1.
Okay.
If I'm using sine, I want to use 0, 0. And I'm going to do that every time for these problems, unless I run into a problem like 3 where it's specifically telling me I have to use one versus the other. But if I'm free to choose sine or cosine, if I'm using sine, I'm going to use a midline point somewhere, so I'm going to use 0, 0. If I'm using cosine, and I got to choose that, I'm going to be using an extreme point, so I'm going to use 0, 1.
Okay, that makes sense.
So I'm purposely choosing sine or cosine so that I get to use the point where the x-coordinate is 0 to make the problem as easy as I can. Now, you don't have to. It's not really that much harder, but it's like a little harder. You know what I mean?
Yep.
Okay. So, Josie, you wanted to do 3, right?
Yes.
Okay, before we got sidetracked, which is okay. These are totally good questions to ask, and it was not related to specifically to starting 3. It was like a clarification thing, which is fine. We can certainly handle that first. Okay, so the amplitude. That gives me that the absolute value of A is 4. The period is going to give me my value of C, which in this case is going to be 2. Again, we're always going to choose C to be positive. So far, so good?
Yeah.
Okay. So, because we have to use cosine, we're told that in the problem, the point from the parent function I'm going to use is 0, 1, and that's a maximum. Again, I want to choose the ones where the x-coordinate is 0 because it makes finding the h trivial. And in my transform function, I have to use the point -6, -9. And we're not told what kind of point this needs to be. But if we're using 0, 1, I have to make -6, 9 either a minimum or a maximum. It has to be another extreme point. I would choose to make it a maximum because since they're the same kind of points, that just tells me the A is positive. Cool with that? Since the x-coordinate is 0, the x-coordinate for the transform function gives me my h. The tricky part now is that the y is not 0. So that is not going to give me the k directly. But here's the way do we figure it out. So remember when we're graphing one of these functions, we use this transformation map, right? And what we do is we take a point from the parent function, and then we take its x-coordinate, multiply it by c, add h, and that gives me the x in my transform function, right? And the same thing with the y. So what we can say is a times the y from the parent function plus k is going to give me the y from my transformed function. Right? That's basically how we generated the points that we graphed. Are we cool with that, Josie?
Yeah.
Okay. So in this case, my A is 4. The y coordinate for my parent function is 1. The k is what we're looking for. And the y for my transform function is -9. So if I subtract 4 from both sides, I get that k is -13. And there's everything I need. Does that feel okay?
Yes, that's another 5 pair.
Yeah. So this is still the same thing that we're doing when we find the h. Just for our reference, we just don't have any algebra to do because, yes, exactly, that this is 0. So we just end up with h equals -6. So we're still doing the same thing when we found our h's. We just don't bother to write anything down because it's trivial. You know what I mean? Elizabeth.
So you always use 0, 0 for the parent function and its sign?
Yes. That's my, okay, so let me just clarify the logic here. I want to use a point in my parent function whose x-coordinate is 0. So if the point in my problem is a minimum, I'm going to use 0, 1 and use cosine, because I have to have an extreme point to match up with an extreme point. If I have a midline point given in my problem, I'm going to use sine, because then I can use 0, 0, which is a midline point. So it matters, I'm going to pick sine or cosine based on the information that's given to me, so that I can use the parent function point that has a 0 for the x-coordinate. That's the order in which I'm doing this. So I'm looking at what's given. Okay, which one does this match up with, sine or cosine? Because I want the point. I want to make sure that parent function point has an x-coordinate of 0, because it just makes everything a little bit simpler.
Yeah. Thank you so much.
Margot.
Can you do some worksheet 3?
I think we did one. Oh, worksheet 3. Sorry. I got confused. Sure. Okay. So here, this is even a little bit easier of a problem, because we have not just like one point and some information about the graph. We have all of the points and we have all of the information. So realistically, the only thing that we're really going to have to use anything other than basically our eyeballs for is going to be getting that h. So I'm going to start by just identifying the midline. So remember, the midline kind of vertically divides this thing in half. So that looks like here at y equals 1. And I remember that the midline is y equals k. So that tells me that k is equal to 1. And that's going to be the same whether we're dealing with a sine or a cosine. That part's not going to matter. So far, so good? Yeah. Okay. Next thing I'm going to do is I'm going to find my amplitude, which I remember is like the distance between a max and the midline, or between the min and a midline. So here our midline starts at 1 and our max goes to 3. So our amplitude is 2. Actually, I'm not going to put a box around that because that's an absolute value. We don't know what A is yet. But that's going to be the same regardless of whether we're doing a sine or a cosine. The next thing we'll do is find the period. I think the easiest way to identify the period is to look from like a max to a max or a min to a min. So I'm going to go from that min to that min. So we started at half a pi and went to 2.5 pi. So the period was just 2 pi. You happy with that?
Wait, so you just use like the...
I'm just looking at the x-coordinate.
Oh.
So it started at a half and went to 2.5.
Okay.
So we went 2 units, right?
Yeah.
And there are pi's on there, but like who cares about the pi's, right? So I know that the period is 2 pi times the absolute value of c. So I know the absolute value of c is just going to be 1 in this case. And we'll just pick the c to be positive every single time. Yes, Jose?
Can you explain the period again? I'm confused because it's 5 pi.
So we're looking at the horizontal distance. So we're starting at a half a pi and we're ending at 5 halves pi, or 2.5. So how far did we go? If you started at half and you went to 2.5. 2. That's the period.
Oh,
So just put the pi back on at the end, right?
Got it.
You cool?
Yeah.
It's okay. It's
I'm
okay.
looking at the 5 and I was like, what? And then,
It's okay. If you missed it, you missed it. It's no big deal. We can say it again. You're probably not the only one, right?
Because like the pi is like a woman.
Yeah, the pi's just a unit name. Yeah, and it would be like be a 1/2 meter to 2.5 meters. The meters part doesn't really matter, right? The pi is just like a unit. Now it matters in like the calculation later on, but like to, you know what I mean, to do the arithmetic, we don't really need it. That's what I want to say. Still doing okay. All right. So the last thing we're going to do then is to find our sine for A and our value for H. So for sine, I'm going to take 0, 0, which is my, I'm just going to do an arrow instead of like writing the word min and max because I'm not kind of short a little bit on space. Is everybody okay with that? And now the midline point from my graph that I'm given is this one, pi 1. Everybody's okay with that? Okay. And I notice that this is, I go from minimum to midline to maximum. So because those are the same type of midline points, I know the A is positive. And because the parent function x coordinate is 0, the transform function's x coordinate is h.
How do you know H? Oh wait, it's right there.
Yep. So same type of midline point, so the A is positive, right?
Yeah.
Again, if I go too fast or you missed it, speak up and say something. That's fine, no big deal. Especially during these question and answer sessions. So okay. Do I have to write out the sine equation? Or are you good with? We'll fill it in. No big deal. You hesitated for longer than I wanted, so I was going to write it anyways. So A sine 1 over c x minus h plus k. And again, you could simplify that down a little bit if you wanted to, like the 1 over 1 doesn't really need to be there, so you can drop the inner set of parentheses and yada, yada, you know. But I'm going to leave it just written like that, so it's clear how I kind of plug things in, right? When you guys go back and look at stuff. Anyways, the next one is if we want to do this as a cosine. So here, I'm going to be using the 0.01 for my parent function. So I'm going to have to go and either pick the minimum or the maximum that's given to me. It doesn't matter which one. For the sake of argument, let's say we picked that minimum because it was the first one listed. So since we're going from max to min, that tells me the A needs to be negative because they're not the same type of extreme point, they're opposite. And then because the x-coordinate from my parent function is 0, the x-coordinate from my transform function is my h. And I got everything I need. So A cosine 1 over c x minus h plus k. Oops, negative 2. Does that feel okay, Margot? Yeah, you're welcome. So again, same basic process as the previous problem, right? Or the problems we were given the description, except finding k is always going to be trivial because you can just pull it right from the picture. You have to find the period yourself, but you're just pulling it from the picture. You can find the amplitude yourself, you're just pulling it from the picture. The only thing that you have to be careful about is choosing which value of A and which value of H. But we're doing that the exact same way for all of them, which is not bad then, right? If it's the same, if that part is the same for every single one of these. Cool.
Oh, I have a question.
Sure, Elizabeth.
Worksheet 1,
Okay.
and what are the signs you have? That could be graphical, like this.
Sure. Does anybody have a preference here, 13 or 14? Let's do 13, I suppose, because the factoring there is someplace where it'd be not uncommon to make a little bit of a mistake. Is that okay?
Yes.
So we'll do 13. So the first thing I'm going to want is to pull the values for A, C, H, and K, because I need those to write my function map or my transformation map, and I need those also to find the amplitude, midline, period, etc. So what I notice straight away is that the leading coefficient on my x inside my function is not 1. So I'm going to start by factoring. So my leading coefficient on my x is 2, so I'm going to factor that 2 out. When I factor this out, I'm dividing, so like 2x divided by 2 is just x. And then pi over 2 divided by 2 is the same thing as pi over 2 times the reciprocal, so times 1/2. So that's going to be pi over 4. And then I'll put a plus 0 at the end to just, so it's easy to see what the k is. So far, so good?
Yes.
Okay. So my a is -3. My c is 1/2. My h is pi over 4. And my k is 0. So far, so good? Okay. So now I'm going to go ahead and write my transformation map. So in this case, I have 1/2 x plus pi over 4, and then -3y plus 0. I'm not going to write the plus 0. So far, so good. Now I'm going to go and take my key points for sine. So in the 10-4 notes, we gave those to you. Well, maybe it was further back than that. I guess it was. There they are. So here's my key points for sine. That would be something that I'd give to you on a test. It would not be something I'd expect you to have memorized. I'm just letting you know where I'm pulling them from so you can go back to do the homework. Okay. So that's 0, 0, pi over 2, 1, pi 0, 3 pi over 2, -1, and then 2 pi 0. So what I'm going to do then is I'm going to take the x from my parent function and plug it into the x in my map, and the y from my parent function and plug it in for the y in my map, and just kind of evaluate. And I'm just going to keep on doing this for each of the points. Is that okay? Okay. And I just did the arithmetic in my head, but I'm basically just adding fractions for the x coordinates. Still doing okay? Okay. Now I'll plot my points. So if I go and I look at my graph, let's see, this is 0, this is pi, so that's a half. So like in the middle there is going to be a quarter. So pi over 4, 0. Bless you. Pi over 2, negative 3. Oops. 3 pi over 4, 0. Pi, positive 3. And then 5 pi over 4, 0. Okay with that? And then I'm just going to extend this following that same pattern to fill the rest of the space provided. So here we go down to a minimum, back to the midline, up to a maximum, back to the midline, min, midline, max, midline, min, midline, max. And I just kind of keep following the same spacing pattern that we established. And I would do the same thing then in the reverse direction. So max, midline, min. And there's what we got. Does that feel okay? Oh, yeah, we should do that, right? So the amplitude is the absolute value of A. So that's just 3. The midline is y equals k. So that's y equals 0. The period is 2 pi times the absolute value of c. So that's pi. And the frequency is the reciprocal of the period. So 1 over pi. And again, those things, again, were in our notes here from this day. Where did we do those at? Where did we do those at? Oh, here they are all. So those are the formulas that I used. You're welcome. Who's next? Not Natalia. Number 2 on worksheet 4. Sure. Hi, Grace.
Hi, can I turn off the lights?
Yeah, no problem. Okay. So, first things first, let's find the values for A, C, H, and K. If I look at the inside of my function, I notice the leading coefficient on x is already 1, so I don't have to do any kind of factoring. So A is negative 3, C is 1, H is pi over 2, and K is 0. We happy there? Okay. There is no amplitude for tangent graphs because there's no extrema. So that we're just going to leave blank or put a slash through or write NA or whatever you want to do. Midline is y equals k still. The period is pi times the absolute value of c. So in this case, the period is just pi. And the frequency is the reciprocal of the period still. So far, so good. We'll write our transformation map exactly the same. So we have Cx plus H, and then Ay plus K. I'm not going to bother writing plus 0. And then I'm going to just use my key points for tangent, which we gave you in the notes right here. Again, not something I'd expect you to have memorized. So far, so good still? Okay. So I plug in my x's into the x spot and my y into the y spot. So I have negative pi over 2 plus pi over 2, that's going to be 0. And then undefined, no matter what you do to it, still stays undefined. And then we have negative pi over 4 plus a half, so that's going to be positive pi over 4. And then 3. And then pi over 2 and 0. And then 3 pi over 4 and negative 3. And then pi and undefined again. So to graph this, I'm going to start by putting in the two asymptotes. So I have one asymptote at 0, where it's undefined. And my other asymptote's at pi. And then if I plot pi over 4 and 3 is here, 0, 0, or I'm sorry, pi over 2 and 0. And then 3 pi over 4 and negative 3. Try to do a better job with this. And then I'm just going to kind of fill in the rest of the space following the same pattern. So first thing I'll do is put in my asymptotes. So we go just like this. And then the same thing over here. Oops. Oh, I forgot this spot, huh? Yeep. Does that feel okay, Natalia? Raylan?
So are the asymptotes always just the x coordinate on the undefined?
Right. Correct.
After you transform it?
Correct.
Okay.
So the places where I should use a different color. So that's an asymptote and that's an asymptote. And the x tells you where to put the vertical line at. Correct. Allie, did I see your hand up?
Yeah, that was my question.
Oh, okay. Regina.
Could you do it on worksheet 5, number 5, please?
Sure. Worksheet 5, number 5. Let me just find a spot for this. So same general ideas when we did this with the sine and cosine ones. So I'm going to start by identifying the midline. So just kind of using my eyes, but it looks like it's this right here. So that tells me the k value. The a is going to be the distance from like here to here. So that is going from -1 to +1, so that's 2 units. My period is going to be like just the distance between the two asymptotes. So that goes from 1/2 of pi to 1.5 pi, so the period is just pi. And I know that for tangent, the period is pi times c, not 2 pi. So I just get that c is 1 then. Good with that? Okay, and then I will set up my transformation map. So the parent function for tangent, I want to use 0, 0, which was a midline point. So the left end pointed down, had a midline point up. The point for my transformation that I need to use is 0, 1, or -1, because that's also a midline point. That midline point, the left end points down and the right end points up. So this tells me that the A needs to be positive and that the H value would be 0. So we can say y equals 2 tangent of 1 over c x minus h plus k. Sure, no problem. The nice part about tangent is there's just one kind of midline point. So you can see immediately, like, if the transformed one is just pointing the wrong directions, you know that A is going to have to be negative. There's no way to get a non-negative A out of it. Well, I mean, you could use C being negative, but like, we don't want to do that. Natalia. So I solved the equation here that pi times C has to equal pi. And then I chose the C always to be positive. Elizabeth?
Can you please do worksheet 3 and 5?
Sure. Oops. Okay, so first thing I'd want to do is look for the K, which means I'm finding the midline. So right there. Next thing I'm going to do is I'm going to look for the amplitude. So that's that distance. So going from 2 to 5, so the amplitude was 3. Still doing okay, Elizabeth? Okay. Next thing we'll do is we'll do the period. So I would go from minimum to minimum. So we're starting at negative pi and we're going to positive 3 pi. Do you see that? So we're starting at negative pi and going to positive 3 pi. So that's 4 pi. And since this is sine, the period is 2 pi times absolute value c. So the absolute value of c is 2, where c is just 2. So far, so good?
Yes.
So all of these things are the same, whether you're doing the sine or the cosine. So the last thing we need to do is just figure out our value for h and the sign for a for each of these. So for sine, we're using 0, 0, which is this kind of midline point. And we're going to have to use that midline point, which is the same kind, right? Because we go from min to midline to max in our graph. So that tells me that the A is positive. And the H is 0. So we can say y equals 3 sine of 1 over 2 x minus 0 plus 2. Is that so far so good? Or if you did it the cosine one, there we're doing 0, 1, which is a maximum. And let's say that we used this one, which is pi comma 5, which is also a maximum. So again, that tells me the a needs to be positive because we're both maxes. And the h here has to be pi. Sure, no problem. Follow-ups on these two? I kind of sped through that a little bit quickly. Is there anything I need to rehash or clean up detail-wise? Sorry, I just got excited, you know? Do you need me to scroll up? You can just ask, like, hey, can you scroll up a little bit? Like, you don't have to play Twister with the line of people in front of us. Or if you just get sick of playing Twister with a line of people in front of you, I think the very first seat in your place is blank, is open. If you wanted to move there temporarily, that's certainly okay too. If you're just like, I'm just sick of this, like I'm going to go sit up here for the next 10 minutes, that's fine too. Braylon.
So for that one, so K would stay the same in that one, but then H would change?
Yes.
Just solve for K?
Correct. So K was the same because the midline, because we have this picture, that midline is going to be in the same spot regardless, right? The picture is the picture. If all we have is a description and we're just told a point, that point isn't necessarily have to be fixed to be a maximum or a minimum or a midline point, like it might be able to be both of them depending on where we want to put it. So in the problems where you have just a description, the K could be different between the sine and the cosine.
So for the most part, when you have like pictures, is the...
If you have a picture, the only difference between them can be the H's and the sign on the A.
Oh, okay, so the K...
The K will have to be the same in a picture. And even if you have a problem where the point you're given is specific, like, hey, this point is a maximum or is a minimum or is a midline point, then the K is going to be the same for both of them. The only place where it can change is in those very first problems on worksheet, whatever that we did, where the question just says a point. If we looked at number 4, where the point is a minimum, there the K would have to be the same between the sine or the cosine one. On numbers 1, 2, and 3, where we just have a point, there the K could be different. Does that feel okay?
Yeah.
So it depends on if that point is fixed as a certain kind of point. Once we've done that, then that K has to be the same for both. Because if that's in the same spot, you know, if it has to be a maximum, then the K has to be here, whether you're doing a sine or a cosine. If this point is just fluid and we make it a minimum, you know, then the K has to be above it. If we made it a maximum, the K would have to be below it.
And that's when you solve.
Or if we made a midline, it'd have to go through it. So there the K could be different. Does that?
Yeah, that makes sense.
Okay. In general, though, we wouldn't have to solve for K unless we told you you had to use cosine to do it, because you could just use sine, where that point, if you pick it to be a midline point, just gives you the H and K, like we had in number 1. So it's only could get weird if it was like the problem in number 3. Megan.
I was just going to ask something.
Of course, no problem. Allie.
So, just a quick question. On worksheet 2, for like number 2, when you're trying to get to the transform function,
Yes.
in your key, it goes from like 0, 1 and like 0, 12 and then to 3, 5. Where does that 0, 12 come from? Is it?
So, yeah. So you're looking at the sine or the cosine version, right?
Yeah.
So if we did like our transformation, and we just account for the A the first time, that would turn into 0, 12, right? Because the amplitude is 12. And then if we're worried about the K, well, clearly it had to subtract whatever 8 unit or 7 units or something, right?
So do you need that, or can you just use that?
You can just use what I did, because
Okay.
there I'm doing it all at once.
Oh.
So instead of doing like 0, 1 and doing 12y and getting 0, 12, and then doing y plus k to get whatever 5, we were just doing 12y plus k is equal to 5.
Okay.
Right? Instead of doing it in 2 steps, I did
Yeah.
it with 1 step, because I feel like it's just easier, because it's the same equation that you do to do the graphing. You're basically just kind of going in the reverse direction or whatever. So it just kind of depends on when I like, these keys are old from when we just started doing this. So like, if you figure out a better way to explain, just so like, do I need to go back and redo this, or like what, yeah. And again, I won't be picky about your work as long as it's like reasonable and I can follow what you're doing. Who's next? Do you want to do more? We can do some more. I know it's been like over a week since I've seen you in person. We've added a lot of assignments, so it's okay to just sit here and grind away at questions for a bit. Margot?
On like the homework files,
Yeah.
can you do number 19?
Certainly. Okay. Okay. So first thing I'm going to do, since it's is identify the values for A, C, H, and K. The way it's currently written, I can just read those straight from the graph. Any issue with that, Margot?
Wait, so do we use
I'm sorry, not read it from the equation. Sorry.
Yeah.
That's okay?
Yeah.
Okay. So one of the things it does is asks for the period. For tangent, that period is pi times the absolute value of C. So in this case, the period is 1/2 of pi. You good with that?
Yeah.
Okay. And then I'm just going to write my transformation map. So that's Cx plus H, Ay plus K. So that just really simplifies down to 1/2 x comma y. Is that okay? All right. And then I'm going to write down my key points for tangent. So these are things that, again, you don't need to memorize. I will give these to you. So here I get negative pi over 4 and undefined. Here I have negative pi over 8 and negative 1, 0, 0, positive pi over 8, and 1, and then positive pi over 4, undefined. Is that okay there?
Yes, thank you.
Yep, and then we just plot this on a grid that goes from negative 2 pi to positive 2 pi and extend to fill the space.
Okay.
Do I need to do that part? Are you good?
No, that's fine.
Okay. Thank you, because that's time consuming and tedious. And I'm very excited not that you're good with not having me draw the picture.
You just scroll over, please. I just didn't finish.
Of course.
Thank you.
No problem. Elizabeth. Oh, stretch on. Who's next? Oh. Well, we're gonna do the homework quiz right now.
No, I know, but like this chapter, what do you think of that?
Oh, next week.
Oh,
Yeah,
no.
we don't do section 3 anymore. So we're not doing that. We've done everything that we need to do.
So we're done.
Yeah. You've seen all the problem types. So we'll do the review next week and talk about what the test format will be like. What?
We're like done learning.
Yeah. Yeah, I've done all the lectures that we're doing for this chapter. Yes.
How many chapters do we have left this semester?
Oh, I don't remember. It's on the syllabus.
Like a lot.